Hi guys, so today I'm going to explain you another backend project which I have made by myself. And this project is titled the Arkham Asylum Backend Digital Forensic Psychiatric Hospital. So I'm pretty sure all of you are aware about this term, that is Arkham Asylum. So if you're familiar with Batman comics, as I am familiar, you know what I mean when I say Arkham Asylum. So that's basically a mixture of a police station and a hospital, where inmates, which I can laymanly translate as the mad peoples, or I can say that diseased peoples, get admitted, get punished, plus gets treated, and then after everything is fine and they are back to a normal citizen state, they are discharged from the asylum. So this project is just an online REST API simulation of such a hospital. This project contains 25 plus distinct API endpoints, which also includes, admitting an inmate, having proper medical records of those inmates, and conducting proper periodic diagnosis so that the inmates are tracked, that they are being updated and enhanced every day, and all sorts of such functionalities which you can imagine in a offline psychiatric hospital. Each and every functionality is being simulated, or at least I would say I have tried to simulate as much as possible in the form of REST backend APIs. So, in order to fully explain this repository, let's come to my anti-gravity local integrated development environment, that is IDE. I can explain this entire repo via getting into each files and folders, but I personally think if I will explain this thing in my local environment, it is going to be much effective and much efficient. So starting from the project overview, whatever I said just now about any digital forensic psychiatric hospital is written here in a professional format. So when you open the README, you will know what this project is in 4 to 5 lines while reading this paragraph. Now, in another section, as everyone wonders when he or she first looks into a repo, that hey, what are the tech stacks you have used? So the core infrastructure, the primary backend language which I have used is Python, that is Django REST framework. I am also pretty sure most of the viewers of this video know what I'm talking about. That is, if not Django REST framework, at least Python. Everybody, whether he or she is inside IT industry or not, knows what is Python. Then in the database, I have used MySQL Workbench. And in terms of authentications, I have used Joshua, Simple JWT. Architectural mapping, I have used Mermaid.js. This is the, I would say, the primary language in which I have coded when it comes to explaining the solution architecture and overall security plus technical architecture of this entire project. So don't worry if you're not understanding these terms. We will look into this in great detail in some moment. Now here comes the most important section, that is the LLM collaborators. So remember in the pre-AI era, we used to have a separate collaborator section here in the GitHub. So seems like I am the only contributor, so that is why not anybody else's name is showing here. So anyways, you got the whole idea. Instead of going for the human collaborators for this entire end-to-end ERP, I have used anti-gravity with the help of Google AI Pro. This subscription helps us enhance the anti-gravity Pro features to next level. I would say in the regular anti-gravity subscription, you will not get access to the models like Claude Opus 4.6 thinking and such. But with the help of these types of subscription like Google AI Pro, you can enhance the models of anti-gravity to a certain extent. I wouldn't say you will make it as intelligent as OpenClaw, but this subscription helps us enhance the anti-gravity to some extent. This anti-gravity is the most important tool which I have used from scratch to this point when it comes to writing core backend logics. Okay, so I would honestly say I have never touched the exact code lines of any of the code files which you'll be seeing inside this repository. All of the coding tasks have been done by anti-gravity. What I have done, I have played a role of client and the technical architect and guided this AI that, hey, you have to code this, not this. Hey, you have made a problem inside this particular function. This particular function, while it returns the correct value from the technical standpoint, but from the architectural standpoint, but from the forensic psychiatric hospitals industry standard standpoint, these things are not in place. Okay. So things like this I have implemented, and trust me, it costed me a lot of effort than a generic person would think. It hasn't been like I have given a simple 4 to 5 lines prompt and the bot made the entire repository. It took me around 1 month of part-time to build this entire repository from scratch. So I would say, yes, I haven't coded into the low-level lines, for example, writing functions, writing variables, defining the comparison operators. No, I have done the job of an architect, or I would say client, which costed my effort. Now the second tool is Perplexity Pro. This tool I have utilized for some online research related to the project. For example, at the starting of the project, I also don't know about how exactly forensic psychiatric hospitals work in general. So things like this, gaining a KT of a generic hospital, then transferring those requirements into my digital infrastructure, things like that I have done with the presence of Perplexity Pro. And then there's the third tool, that is OpenClaw. I don't think I have to say anything about this AI. This AI has sat on top of my laptop watching all the models like Perplexity Pro, Anti-Gravity, whatever these small bots are doing, and gathered the context of entire project from starting to ending, and also including the present state, just like me. And this bot helped all the small bots guide that how to proceed according to the industry standard, like industry standards of coding. So, any small, or I would say random bot can code. If you tell any bot to write a function which will return this value as based on XYZ prompt or XYZ parameters, any bot will do it. But whether that function is actually fitable to your entire repository, whether that function is actually in alignment with your vision when it comes to the overall project which client has demanded, that is the most important question. And that is where our job as a human developers come in. So I would say OpenClaw, to a very great extent, helps solve us this problem. Okay. So on times when tools like anti-gravity has coded some requirements which is like slipping through my overall vision of the project, OpenClaw pictured in this bot guided the small bot, that is anti-gravity, that hey, this is not what we are expecting from a digital Arkham Asylum. You should tweak the function in such a way that the logic should handle in this way and the output should come this as compared to this. I'm just telling at a high level, okay, so that you can understand. I'm not going into each and every technical functions, showing you the code. This is just a high level explanation of what OpenClaw and how it has contributed. Now here comes the next section, that is the key features. So before going to the each and every code lines, how I have written the CRUD logics and all, I wanted to highlight some three key features of this project within the backend that I have implemented. The first one is admission engine. This engine triggers when someone wants to admit an inmate to the asylum. We will see all this in very in detailed format in the form of code just a moment from now, but let's understand this from a high level perspective. Let's understand this feature excluding all the technical jargons, just as if we are a non-technical managers. So what this admission engine does, whenever a super admin of this asylum wants to admit external inmate, okay, into the asylum, this engine triggers. And what this engine does, this engine checks the inmate profile of that inmate, which super admin is going to be submitting. This inmate profile is required. I want to be very clear and blunt about that. Super admin, just because he's super admin, cannot admit any inmate of his or her liking. The inmate should have an inmate profile, and within that inmate profile, it should have a medical file. And within that medical file, it should at least have a medical diagnosis report, which specifically in the context of this project has been referred as preliminary diagnosis. So if this field is present, only then the super admin, via virtue of this admission engine, is required to admit that inmate. We will, and I'm pretty sure there are a lot of functionalities that has been implemented within this admission engine, but we will look into that after some moment. Now here comes the second feature, that is transfer shift safety engine. What this does, this engine basically ensures whenever a security staff of the asylum is moving an inmate. Moving an inmate, for your information, is a very critical and risky task in any asylum, not just this one. So inmates, as you know, are a little bit mad, little bit criminal type. So moving those inmates from one cell to another is a very risky job. We all saw in Bollywood movies, Hollywood movies, that whenever like security staffs try to move an inmate from one cell to another, that inmates basically escape the entire asylum. So you need to ensure double security when you are moving an inmate from here to there. So, and that the responsibility of ensuring the security goes to this transfer safety engine. This engine basically does that whatever the target inmate is, which a security staff is trying to move, this engine checks that this staff is having a updated medical record. This inmate, on the other hand, is having a updated inmate profile. And by updated, I exactly mean that whether these files have been in awareness to the doctors and the super admins of this asylum. If this is true, then transfer safety engine allows the security staff to move the inmate to whatever cell block security staff is wanting to move based on the cell blocks availability. We will talk about this functionality later. I'm talking about the cell blocks functionality. This is a separate functionality. We'll talk about this later. But this is what the transfer safety engine does. Now here comes the immutable audit logging and zero trust. This functionality basically logs all the CRUD requests to each and every model we are having. into this entire project. So any person hitting any request, whether it be a get request, post request, put request, whatever the request is. As you know that this is entirely a backend project. So that basically means this project contains a lot of APIs and nothing else. Okay. So anybody, any user, if he or she will make any kind of request to any API endpoint, that will get logged under a separate table, which here we have referred as audit log table. And via reviewing this audit log table, a super admin will able to know that, okay, this person has touched this database, performed this action, the intent was this, things like this. This is specifically made for security. Now here comes the security architecture. What kind of security implementations I have done within this project? So a simple backend project, if you can imagine, how would it look? We have lots of tables. We have CRUD logics implemented over each table. Forget about security, forget about business context, whatever the hell it is. If a user wants to use that particular generic backend project, what he or she will do? He or she needs to figure out that, okay, what I need to do, and based on that, he or she will be intelligently CRUDing the proper tables based on his requirement. This is not the case here. We have blocked each and every dead endpoints, orphan endpoints, endpoints which are not required for the particular user. For example, if someone is a public visitor, why he or she needs to see the audit log table of our entire asylum? That's the business context, right? So we have blocked any such users to enter our sensitive audit log table. So these kinds of role-based access control RBAC we have implemented. Here is the list of all the such security implementations we have done. Okay, just a brief list. You can go to securitytestreport.md to view a detailed list of this. And most importantly, as always, you can view each and every code files, business logic, where it is implemented, how the request is being handled by the backend to gain the entire security context. Now here comes the project structure. Here you will, instead of hunting through each and every directory and knowing what this file contains, what this file is all about, you can just refer to this project structure directory, where you will find all the directories and files and their one-liner description of what it does, or I would say why this file is here in this entire project. So just for a reference, I would say this is the views.py file, which you will find under Arkham app directory under our root directory. This is the actual backend implementation. Okay, when I say actual backend implementation, what do I mean? In this file, you will find the actual logic, error messages, success messages, how many endpoints are there, how our system is handling each endpoint, which all are the users that are required to use that endpoint, what are the serializers we are using when it comes to that particular endpoint. These are all types of crucial core backend information you can find under views.py. Now, here comes the architecture documentation, which I would say the most important across any project. So what this architecture documentation explain? The overall architecture of a project, what it is doing, what it is not. Here, I know I have explained pretty much a lot about this project via talking about these types of implementation. But I would say at a bird's eye level view, what this project is all about, what it is doing, what particular business problem it is solving, you will be able to know all sorts of types of this information within the HTMLs. Okay. So let me open a HTML for you. This is the solution architecture. This is specifically made for non-technical stakeholders. Suppose someone here, or I would say, if you are the kind of person who is not that much familiar about IT industry, who is not that much familiar about these codes, CRUD, what is backend, what is front end, you are just, I would say, a lawyer, a mechanical engineer, or anyone which is not inside the IT industry. How will I, as a core technical person, will be able to explain this entire project to you? Here comes the solution, that is the solution architecture. With the help of this architecture, this is the entire diagram, or I would say the skeleton of the project, which excludes all the technical jargons. Okay, which excludes all the technical jargons and explain this project in a simplest possible manner to any non-technical stakeholder. So you cannot be able to view this document in this way, right? This is too messy if you are a non-technical person. If this is an HTML file, the first thing you should do is to open this file with Chrome browser. So for example, if I'm here using the Comet browser, I can open this document and have a look around this solution architecture, each and every detail which is been mentioned in the form of code. But I will not do that. Why? Because the diagrams which I have injected into this file are not zoomable if you open this file from any browser, not just Comet, not just Chrome browser. But in order to explain the diagram in detail, I need to zoom into each and every component. And which is the reason why I have extracted the diagram, turned it into an image, and saved it offline under my this PC. And I will be explaining you this architecture from that image. But you can find the same image when you open this file under your particular local environment from your own browser. This is not going to be different anyway. The UI will look different. For example, in the images, I am using light theme, whereas if you open the same HTML file from your browser, you will find dark theme. Some sorts of UI will change, but the core information will not change. I am guaranteeing you that. Now let's look at the solution architecture. This is the our solution architecture for the entire Arkham Asylum. Now here you can see we have four kinds of user groups. I have exposed endpoint sets for super admins to create more groups, manage existing groups, delete existing groups, and all sorts of such things. But within the context of this project, only four user groups are required. Then why would I have exposed those endpoints at first place? Just because they are super admins. Super admins should be able to do anything of their liking. So that is the reason why I have just exposed those endpoints. Whether or not you wanted to use it as a super admin, that is totally up to you. If you want to create some another group, you can create. Feel free to do that. So let's look at the first group we are having, public visitor. Here is the security gate. Okay, how will I be able to, or I would say, how will the system will be able to identify that you belong to this group, you belong to this group, you belong to this group? How will attacker cannot be able to impersonate this group if he belongs to this group if he belongs to this? These all sorts of questions are handled by our security gateway. This gateway, the first thing it does is identity verification. Whatever request you're gonna hit from Postman, this gateway will ensure whether you are belonging to any of these groups or not. And I'm telling you this, if you are not belonging to any of the groups, if you're just an authenticated user, if you have obtained the token from JWT, this gateway will not gonna give you the permission to enter into these zones. Okay, so forget about viewing the database files. This gateway will not even allow you to hit the core business system modules. So this gateway explicitly require you to have at least uh, public visitor access. If you are a authenticated user, if you're just an authenticated user, I would say you at least register yourself as public visitor so that you are having at least view access to all the inmate profiles here. Okay. So now all sorts of rate limiting, access control, which users should view what these types of things are controlled by this. Rate limiting, I would say, if you are requesting more than the limit. For example, if I have told this system to allow only 10 requests per minute, if you are hitting 12 requests, 15 requests, this system is just going to deny all your requests, which comes after the 10th request. That is what rate limiting or anti-spam module exactly means. Now, coming on exactly to the RBAC functionality, public visitors are having only read access to the inmate management profile. Okay, they can see who all are the inmates, what cell block are they are in, what are their aliases, sorts of those information. Then super admins, they can do whatever they want, no question. You can understand just by looking to the name that is, if they are super admin, they can do anything throughout the project. Now here comes the security guards. Security guards are required to view the inmate profiles just as the public visitor, but what makes them different from the public visitor is that they are able to transfer the inmates. They can open the lock, pull the inmate from one cell to another. This is the exact unique functionality which differentiates our guard boss from public visitors. Got it? Now the third group is medical staff. And these are groups. Please don't forget that these are not users, these are groups. Though in the architecture diagram you can see names like Dr. Leland, Warden, which take you to the confusion that these are groups. No, these are groups. Okay, these are not users, these are groups. In these groups, multiple users can get registered, which depends on super admin. Super admin can only do this. So medical staffs can view the medical records only. They are not, I would say, allowed to view the audit tables or manage groups, create and delete existing. These are admin exclusive. Okay, so medical staffs can only view the medical records along with the inmate profile. This shouldn't be a question, because inmate profiles and medical records are linked to each other. They are depicting which inmate holds which type of medicals or diagnosis. Okay, so this is the core business system. You will find inmate profiles, you will find admission engine. I will come into this later. You will find medical records, you will find audit and watchtower, staff control. Okay, this I'm sure you know, guys. Medical records, I'm sure this is also clear to this point. Now, admission engine. What is this admission engine? We have just talked about this functionality here in our readme. The admission engine. Those kinds of security checks or prerequisites which are applied over the super admin, which are blocking them to admit any inmate of their liking. This is the particular functionality. Okay. Whenever a super admin tries to admit any external inmate, this engine kicks in, and then it will allow the super admins to write into the low level inmate database. Now, audit and watchtower. This is just a module which allows super admins to view security logs of each and every users security logs, as we just talked about. That these are the logs of each and every API request which has been made to the system, whether get, whether read, or whatever it is. Now, group management, I have just told you that admins are also provided an additional functionality to create and manage groups. This is just talking about that functionality, which handles by personal roster, that is staff identities and rows, low-level database. So here in your MySQL workbench, this component you will find under the name as auth underscore user, auth underscore user underscore groups. So these types of table are actually the representation of this module. So if you know Django at a low level like me, you know that Django already exposes lots of authentication and authorization tables like auth underscore user and such, which saves you weeks of development time as a junior backend developer. Now here comes the solution architecture. Coming on to the README, we have covered the solution architecture. Now it's time to look into the technical architecture. Low level Django request lifecycles. How exactly a request which has been head to our server is being handled by the backend, and how exactly the response are served to that user. We will see that. Client tools. Okay, this is the user. What the user will be using, either browser or the Postman. Okay, so with the help of Postman, he or she will request all our defined endpoints. Their request will first go to the middleware pipeline, where we have some built-in middlewares like security, session, common, auth. These are being handled by the jobs, for example, expiration of the tokens, reissue of the tokens, and maintenance of the session ID. These types of things. Course middleware, thread middleware. This is my custom created middleware, that is thread local middleware. What this middleware is doing, we will be listening to this right after this segment. Okay, when I will open the temporary technical architecture 2 image, not P1. So let's keep it as a secret for now. Now, thereafter, the request hits the DRF security layer, the one which we have just talked about in solution architecture. JWT authentication, Mr. Who are you? Why are you accessing? Are you trying to access this endpoint? You are not eligible. Questions like such. These are being handled by DRF security layer. Throttling, all types of performance issue. Mr. You're not allowed to hit this endpoint more than 6 times. Okay. Things like such are being handled by throttling. Authentication, authorization, and throttling. These features are here in the DRF security layer. Now then comes the application layer. This is the most famous layer where all the backend developers like me works. Okay, our endpoint then hits urs.py key, hey, which is the endpoint which you have made the request. The router will then handle to the proper view set, that if it is a request related to inmate, please hand it out to inmate view set, medical view set, cell block view set accordingly. Now serializers, these are used to write to the database, and these are also used to output the JSON format. In the JSON format, whatever there in the database, this serializer will convert those into JSON format, and then this serializer will throw this JSON format to the users, so that they can see what they are writing in the post request, or they can see what they want to see in the form of a get request. Now here comes the temporary technical architecture 2 diagram, where we will actually uncover the middleware which I have implemented in the custom format. Now view sets in actions. Okay, we will see each and every view set in detail, what they are doing and what they are not doing. Now let's have a look into all the view sets and how they are acting with each other. So here we are having a lot of view sets: security view set, user group view set, cell block view set, inmate view set, medical view set. Wait, let me show you these view sets actually in action. So I will go to Arkham app, views.py, and here you can see all the view sets which I've used. Security view set, inmate view set. These are all the logics which are helping the backend system handle the CRUDs, medical view sets, cell block view set, user group view set. So these are the view sets which are mentioned here in the second technical architecture diagram. Now all the view sets, whenever a request comes to our backend system, that gets into the urs.py as we saw earlier. This urs.py decides which request will go into which view sets, as we have just saw. So for example, if that request is related to cell block, this will go into cell block view set, and then cell block will transfer to its proper database model. For example, cell block, we are having a database for it. We will see all the database and their respective tables just from a moment now. But let's see here. So whatever the request user will make related to user group view set, security view set, anything, these view sets will direct that request to their proper serializers, or I would say proper models. Audit logging, as you know, it is a security feature, so that's why this logging is attached with this component. These inmates are going to inmate profile, then the user built-in. This is the built-in components which handles the user's CRUD. Then we have medical file. Uh, we have many to one-to-one relationships with also. So these models are not independent in nature. So we will have a look into this in very great detail. So for example, medical file, as I have just told, that each inmate will be having a separate medical file. So that's why we need to link this user module with our medical file module, right? So that's why we have implemented many to one module. Then we also need to link the inmate profile with our medical file, as we have just saw in the solution architecture, that each inmate will be having a dedicated medical data like diagnosis, medications ongoing, things like that. We have used one-to-one relationship between these two models. Then all the requests, like how all the requests are getting logged into our audit log table, this is being handled by this audit pipeline component. So how this pipeline actually works, right? This is where exactly our middleware lies. This is the custom generated middleware which we have just saw in the previous diagram, which is called thread local middleware. The primary job of this particular middleware is to fetch the current user who has made the request and keep the current user variable maintained throughout the request life cycle. So the moment request enters our middleware, to the response has been served by our backend to postman. This is the duration in which thread local middleware extract the username and keeps it persistent so that any other function, or I would say module in our backend, uses this user ID whenever and wherever required. So this is the job of thread local middleware. And Django signals, when I just said, right, that any module or any segment of our backend uses this middleware whenever and wherever required. So what are those modules? Those modules primarily are Django signals and then the audit read decorator. So these are the watchdogs which are exactly performing the action of analyzing the incoming request and writing the audit log table. So for example, if I myself assume myself as a watchdog, either I am Django signals or I am the audit underscore read decorator, I will see, okay, user has requested read under this particular endpoint and he has passed this particular JSON object as the payload. So I will write all of these informations intelligently according to the audit log table. I cannot just screenshot this and paste it into our audit log table, right? I need to find proper columns. Okay, where is the column which depicts actor name? I would intelligently grab the name and store into the audit log table. Then I will see, okay, where is the column which will depict the subject or the input data which the actor has sent to a particular endpoint. I will locate that and intelligently link that particular component with the JSON object which user has sent in the postman as payload. So these types of intelligent work I need to do, right? This is not just a layman copy pasting task. So that is why I have created two watchdogs, you can say, who will be performing this action. The first watchdog is Django signals. This watchdog is basically responsible for logging all the CUD operations. For example, CRUD, update and delete. Okay, so these three types of informations out of the entire CRUD set we are having in our backend, these operations are being responsible by Django signals. Then we are left with R, that is read, out of the entire CRUD, right? If we stripe out the CUD variable, what we will be left with? R, that is read. This audit underscore read decorator is handling our read operations. So out of the entire CRUD, CUD is being logged by the first watchdog and read is being logged by our second watchdog. So this is how our entire audit pipeline feature is working. Now if you match all those lines which are coming in, for example, update, right? When if you see user group ViewSet, if admins want to update a user, the line will straight take the admin to the user table, correct? And then the user table will straight take the admin to as an update action to this Django signal. This will not take the admin physically. I would say when the admin performs his particular requirement from here and returns from here itself, Django signals will see that someone has touched this particular component with an action of update, and it will record in our particular database that yes, this particular actor has done the update operation with this payload at this endpoint. So things like this are being handled by our audit log pipeline. And now you can analyze all the arrows like retrieve, then write operations, then COD, all. You can now understand each and everything related to the functionalities which has been showcased here. Let's come to the another segment of our technical architecture. This is the view of all the endpoints we have created and how, like for example, what all URLs are available for us to hit the request from postman. So this is the local server. We have /admin, we have /API auth, we have /API v1. This endpoint is basically handling all the JAWS plus JWT authentication stuff. For example, logging functionality, refreshing the token, verifying the token, changing passwords, all sorts of this. The admin panel is just I would say a dummy endpoint which I personally have created to ensure that the server is running and live. Okay, so if I am having a postman and at some point of time my mood tells that okay, I will test my Arkham Asylum now. So what will be the first endpoint that I should hit? It is just a dummy endpoint /admin, which will reply us back with a sample message that hey, the server is live and you are welcome to touch any of the available endpoints, things like that. Now I have stored the entire endpoints under this particular path, that is /API/v1. This is the particular location of our application containing all the sets and group sets. So if you hit something like localhost port 8001 /API/v1 /default router /inmate, if you will perform get request, it will output the list of all the inmates. If you will perform update request, it will update the details of all the inmates, things like such. You can now while looking to this map, you can view and make all these endpoints by your own. Localhost /API v1 /JWT verify, you will be able to gather an information of all the endpoints available throughout the system. So I have used something called default router, which actually does the job of creating all those paths, managing all those paths. For example, if some path is a dead path for throughout the context of our entire project. For example, someday I decide, okay, super admins will not be using security logs anymore from now. So the default router, what it will do, it will simply forfeit this particular component, and after that, whenever a user requests this particular endpoint, it will throw a custom 404 error. So these types of things, instead of manually managing all slashes, these types of headaches are being offloaded from my head via this default router. So that is why I have renamed it personally myself as the default underscore router. This is not like a mandatory thing which you have to implement in your project when you are making. You can completely skip this, because I know this will be a kind of backend user experience where the front user will know, okay, you are using the default router component. Okay, so if you want to forfeit this, you can completely forfeit this. Default router functionality doesn't mandate you to use its name right in front of the URL address bar. You can completely forfeit that and use simply like /API/v1/user groups. But the reason why I have implemented is that I have lots of other components as well, right? API v1, auth, JW create. So how can I verify, or how can I differentiate what endpoints are being handled by my other components and what endpoints are being specifically taken care by default router? So that is the reason why I have created an independent explicit name of this endpoint. Now let's come back to our README. We have covered enough of the technical architecture HTML. Okay, now moving on to the database ER model. So what all database are we having? What are the relationship between each and every model? This particular HTML file will depict you in detail. Instead of opening the architecture as these types of white diagram, I will now simply open the HTML file itself. Why? Because there is no need to zoom in the diagram here. You can see all the way by here itself. Let me increase the brightness. Entity relationship visualizer and technical field documentation. As with regards of understanding any human body, you should always needs to understand what are the warehouses of this human body. Okay, for example, stomach, for example, heart, where our blood gets stored, stomach, where our food gets stored. So for example, in this project, where is exactly, when we are referring to inmate profile, medical details, audit log table, where exactly are these details are getting stored? This database ER model and schema document answers this question. So at first we are having a cell block table. Okay, this is the table definition. This is the primary key of the cell block table. Almost every table you will see the ID column as the primary key. First column of every table is depicting the data type of that column, whether it holds integer, string or not. Then the second column depicts the name of the column, ID, username, email. These are the names of the column. Now the third one indicates which exactly is the primary key, foreign key, or I would say the nature of the keys, or in more simpler terms, the nature of each columns, just between primary and foreign. That's all. We have not included additional natures in this. So for example, if you see the inmate profile, here we are having ID column as primary key. This is expected from each and every table if you are having some sort of deep understanding of SQL. Now we are having another column which is named as cell block ID. This is the foreign key. It means this column, the values inside this column are being referenced or are being influenced or are coming from any other table. What is that table? We don't know yet. But just by looking to this FK indicator, we can assure this. Now the last column is depicting the maximum, I would say the upper limit of that column. So for example, username can only hold up to 150 characters. Email can hold up to 254 characters, things like this. If we reference exactly with this column, we have known that this cell block ID is a foreign key. Now we can also conclude that this has a many-to-one relationship with the medical file table. Okay, and exactly which column here the cell block ID is referencing to, we cannot say. We can just say that this is referencing to this table. In order to view that detailed information, you need to manually go to your MySQL workbench, open it and inspect intelligently by your own. Okay, so that extent of detail I have not implemented right now in my database ER model and schema. And if you scroll down, you will find many more tables like audit log. This is the information of how and like how we are capturing the actions of each and every user, which will go to our application. Now here you can find all the English-based explanation for each table, purpose, constraint, type, what we have just discussed now here visually. So this contains all about the database. Now moving to the next section of README, we have the quick start and local setup. Just as you do with any other repository in this GitHub, clone it, cd, activate the virtual environment. This is Python specific. If you have worked with Python a lot of times, just like me, you know what a virtual environment is and how to manage a virtual environment within a particular project. So for example, this virtual environment mainly go within hidden system folders of Windows. But here what I have implemented is that I have created and maintained the virtual environment right here in the project root, so that I can see exactly from my eyes what is going inside that environment as I progress in my project with respect to time, and also some of the like external, or I would say the inbuilt scripts I can use to enhance my management of this entire project. For example, if I can show you, I have created a script to populate the database. So whenever you will download, or any other user like you will download the GitHub repository, right? So what he first needs to do is to populate the database. After setting up migrations, database, and everything, the first thing you should do before starting to use this project is to have some sample rows feed to your database accordingly, not just a random values, right? If that is an inmate profile, you need to intelligently input some sample medical names, some sample inmate's name, things like that. So this is a very heavy manual duty, right? So in order to automate this, in order to provide that much ease to our users, I have created an automatic Python script via the help of anti-gravity, I would again say, to automatically feed some sort of sample rows to each and every tables we are having, right? So you see here these tables. So this script, if you run it properly, it will inject at least 10 rows to each table what we are having in our workbench. So for example, here I can show you the sample credentials, okay, which this script is feeding to our inbuilt auth underscore user table. Bruce, Batman, super admin. This is the username, this is the password, and this is the user group that the user will belong to. This users underscore data object is like very important for you if you are exploring this project, because you need to at any given point of time remember the username, password, and generate tokens accordingly to experiment with the endpoints, RBAC feature, and other kinds of security feature. So that is the reason why, instead of just keeping this user underscore data in the form of code, I have created a separate users credentials underscore md type of file. Let me show you that. This creds.md. So this file will help you to have a human level constant look of all the users your database currently contains. And according to this, you can generate username, password tokens, and feed that tokens across your endpoints in the Postman to explore the application. Now moving on to the another section of README. After seeding your Arkham database, you can also test, as we are just discussing. You can test the all the endpoints. The options you are having is you can test either manually, or I have also done the job of automation testing of all the APIs. I have offloaded this much headache of all the users, that if you are having everything set up to the mark of README in your local environment, and now you are had to test the APIs, instead of manually hitting all the 25 to 30 endpoints I have created, you can just run a automation test script which will verify all the endpoints are working or not within your local environment. And also it will give you a report of all the test cases, like what test cases has been failed, what test cases has been passed, what were the sample payload, what we got as a sample response from the server, things like that. I will show you a sample functional test report. So this is the report which I have generated when I was last testing my all the API endpoints set. So you can see when you will run the script, you will be having these types of terminal, and some sorts of observation which I have did. For example, all the 27, I have performed 27 assertions across my automation test scripts. You can enhance each and every script to include more edge cases as much as possible, whatever you are liking, right? So currently I have tested only the happy pass for each and every endpoint. For example, test inmate retrieve public, whether an inmate is appearing onto the public records or not. These types of test cases I have implemented here, asserting the response code, asserting whether medical record is present in the response data or not. And for example, if I show you a demonstration of a post request, this it will be test admission success. So what we were talking about, admission engine, right? This particular test case exactly tests that whether an inmate is admittable to a asylum or not. This test case is exactly testing that. So the script has provided this automated payload as an example, and the script is trying to inject this into our records and testing whether the transfer engine is passing or not. This is the API endpoint, this is the payload, and then all the assertions of proper status code, that whether we are receiving 201 created. If it will throw an error, the automation script will just throw the same kind of error along with its intelligent to our terminal. We then having inmate profile get band name. So it is not just asserting the response status code, it is also asserting that whether exactly our database contains the name which we have just entered or not. So although we are having a functionality to return to the user what we have just updated in our database in the form of a combined JSON object, but our test case skips that part and directly go to the database, test there that whether I have inputted what in the postman is exactly available in the database or not. Okay, so now moving to the next section of README. So this was all about functional test, right? I have defined lots of functional tests in lots of different profiles which you can run and test via just a single command, and that is PyTest. You will find all sorts of information in the report itself, okay? And if not, you are intelligent enough to explore and find out the ways for those. Now the second test suite which comes is performance testing. Not only functional testing of any project or any backend is required, but we should also do performance testing as well. Okay, whether the APIs are able to handle that much amount of load which we are about to give, whether the APIs are returning proper error responses after a particular threshold has been met, whether the APIs are properly serving the request up to the marked threshold or not, or is it the APIs are failing in between. Assertions like this we will make in performance test suite. So this is the instruction to run my performance testing, which I have created. I have basically created a performance testing script via the help of external tool called Locust. Okay. So this is the script basically which will help our Locust web interface run, and that interface will be helping you as a user to perform whatever performance testing you want to do over the backend. So for example, if you decide, okay, I want to run a simulation of 1,000 users over my backend application, that web interface will allow you to do that, and this script will allow that particular web interface to allow you to do this. Okay, so this is a chained way of three components. First one is our script, which is the very low level. Then in the middle layer, our web interface is sitting, that is the Locust performance test web interface, which you yourself will see when you will run this test script. And then at top, you as a user is sitting into the application layer who's commanding how to do performance testing. Now, the next segment is security testing. After functional and performance has been done on any project, the third type of testing which you will do or which you should do is security testing. Whether your application is standing by all the security, whether your application's data is available at proper time to the user, whether your data is confidential, means whether admins can see only their data, medical doctors can see only their data, whether these types of things are ensured or not in your entire backend project. Security testing handles all sorts of this. So this is just a simple command which you can run in your terminal. This will basically do the automated job of grading how well your APIs are performing when it comes to security. I have created a detailed report in terms of security, like what all are the vulnerabilities which are available in our system or not. So what I've basically done, I have not fixed these vulnerabilities, and that is why, because of the nature of these vulnerabilities, these all reported vulnerabilities by the automated terminal command basically belongs to the deployment part, whether a application is working fine in the deployment production environment or not. And as you know, this is just a learning project, which in most of the times will be running in stakeholders' respective local environments, so which was the reason I have not fixed, or I have not even tried to fix these types of security flaws. But I have taken a note of these endpoints. I have taken a note of this report, and I will try to mitigate whenever I will try to send this project to my production environment. In this layman's vulnerability detection section, I have noted down the exact found bugs along with my reasoning of why I am not fixing those bugs in my local environment. So you can take a look at this section in detail. Now the next section is production mitigation demonstration. This section tells that if tomorrow I decide to push my personal local repository to the DevOps environment, so what all are the first security measures that I will apply there? So basically, these bugs belong to the DevOps environment, right? But we are not working in the DevOps environment currently. If tomorrow we decide to push our project to the DevOps environment, how will I fix these bugs? These bugs will be fixed by putting in these demonstrated code lines. Now let's move to the next section of security. Okay, so security report has ended here. Now here comes the most interesting part of any backend project. This is the section what every backend developer like me looks for into others repositories. So here, as you can see, I have created and I have documented a total of 24 endpoints related to this project. Here, the table is formatted in such a way that you will get almost all the information related to an API endpoint. For example, the request method, you need to put in the postman, the endpoint, the authorization level, whether this endpoint should be called by a super admin, medical staff, or simply guardrails, whatever this is. Sample payload, what all payloads you need to send to this endpoint so that the request comes as expected, right? So here you are seeing the token, the access token of the users, and the description of each endpoint, what each endpoint is doing at a high level. For example, here you can see list all inmates. This also supports question mark cell underscore block filter, retrieve single inmate, admitting an inmate, all sorts of such informations which any backend developer requires while testing an endpoint or while analyzing while analyzing an endpoint created by someone other. So things like this you can find in this API endpoints reference section, which is the last section of our readme. Well, now let's have a close look to a endpoint, and let me explain the low-level request journey from the moment it touched our backend system to the moment the postman served the expected response. So I'm taking this 11 endpoint for my example because this contains some exciting features like admission engine, atomic transactions like this. So whenever, let's suppose that you hit this endpoint in your postman, okay, you obtained the token of super admin, you have given this payload in your postman request body. Obviously you're not gonna paste exactly this, you will require to have a proper name, have a proper alias, then cell block ID and all sorts of informations. You will intelligently transform this payload template into actual data containing payload JSON, and then you will fetch this JSON to the postman request. So suppose you have thrown this request and the request is now inside our backend system. What we have talked? We have talked urls.py is the first file where our request will come. So let's open that file. I will go to app, then urls.py. Let's have a look at the endpoint. So here we are having lots of endpoint, right? On which particular endpoint the request will come? You have catched it, right? This is this endpoint, inmates. And how we have known that? If we go to the endpoint again, see here, API v1 default router inmates. We can again go to the URLs. Default router is the endpoint, and then inside this default router slash inmates. This is depicting exactly this. And why slash is not here, unlike here, is because of this code line. We have disabled trailing slash. So this is a kind of security feature which will let the attacker at least remove one special character. So I cannot exactly explain why I have written this, but this is you can understand this thing as an industry standard security practice. It is always recommended that that inside each and every endpoint, the last part of that endpoint shouldn't contain trailing slash. Okay, so that is why in our readme documentation, in every endpoint, you will not see any kind of trailing slash at the end. See here, here, here. Okay. So now our request reaches here, and then this urls.py redirects our request to the proper view set inside views.py file. Let's try to have a look. So here things start getting complicated because this is the core business backend logic. Okay. So no problem. I will explain you one by one in detail, but for only one request. Now it's your job to go through each and every endpoint, simulate inside your mind how the backend is taking the request and serving the responses. But let's try to study the endpoint number 11. So inside this view set, our first code line gets something like query set equals to inmate profile.objects.all. What this is saying our backend system to fetch all the rows related to this model. Let's go on this model. So here under models.py, we used to define all our tables, or in technical terms, I would say we used to define our schemas. Okay. So inmate profile is our schema or a model or a table, whatever you are like to say. Inside this table, the first column we are having is name, models.char field, max length is 100, unique equals to true. Okay, this unique equals to true means if you try to pass same name across multiple endpoints, those requests will be rejected by Django, because here unique equals to true means only one name should be available throughout this model. So duplicacy is not allowed here. Same is the definition with our another column, alias, cell block, status, and like this. Let's try to have a close look to this cell underscore block column. It's unlike name and aliases, it says something like models.foreign key cell block. So it basically means values which will come under this column will not be getting updated by the user from an outside postman. The values will come from a cell block model. Let's go to this model here. See, right above the inmate profile, I have defined our cell block model. So cell block model contains name, max capacity, and all sorts of other information. This is like out of the scope of current endpoint which we have taken to study. But anyways, you just remember that inside the cell block column, values will come from this model. Okay, and exactly which value will come inside this model, you have to think on your intelligence. Okay, so this is not anywhere defined in our code line, but let me think through, and you also think through alongside with me, and let's come out with the exact value which has been taken care from the cell block. So here, this is the profile of inmate, right? We have the inmate's name, we have the alias, we have the cell underscore block, which depicts on inside which cell the inmate is. Okay. So now come to cell block model. Here, this is the name of the cell block. This is the max capacity. Now, via intelligently thinking, you come to understand that okay, name is the column which specifically has been related to this inmate profile. Why? Because we need to see we need to see the name of the cell block at a particular name of the inmate profile is in. Got it? Now here comes the another segment of the same foreign key function. On delete equals models.protect. What is this doing? This is like ensuring only at a specific condition a particular cell block is allowed to be deleted from superadmin. And what is that condition? If all the inmate profiles, okay, related to that particular cell block is vacant. So speaking on a high level business terms, you can only delete this cell block table only if all the inmates inside this cells has been moved out to another cells. That is what this particular SQL condition technically saying. Now related underscore names inmates. So this is just like the thing which we have just talked about. Now similarly, we have the status column. The default value of this status column is active. See here in our sample payload, we have not anywhere defined our status value, right? So what will be the default status value? It will be active. Whenever you try to admit an inmate, the default value that inmate will get is active. If you want to change it, no problem, you can change it. It is just the default value. And while changing the status value, what is the thing that you need to keep remembering in your mind? Status underscore choices. I have implemented only a set of whitelisted choices which you can append to a inmate while admitting it to this asylum. These are active, discharged, transferred, escaped, deceased. Deceased means when an inmate died. Okay, so this you won't be using while creating an inmate, but this you may use whenever inmate suddenly dies in our asylum. So that particular existing inmate, you just change the status column to deceased. Now, what escaped means, this is like classic Arkham Asylum status. Escape means the inmate escaped out of the blue in the night when the guards are sleeping or whatsoever. Transferred, when the when a particular inmate profile has been transferred to any another asylum out of the context. Okay, so we need not to remember about those asylums. Those are, you can say, imaginary asylums. I have not implemented anywhere those outer asylums. So we need to change the status as transferred if an inmate is being transferred to any other asylum. Discharged, if the inmate has successfully cured, treated, and punished, and now the inmate is equal to a normal human being, we will simply discharge that particular inmate from our asylum. That, hey, please go into your streets, into your home, whatsoever, and live your life happily. Active, we just talked about. Now, def str function. What this function is doing? This function is telling which particular values of the column I need to display into the admin table. Okay, so inside the Django admin panel, right? If you view this model or any other model, it will not show you all the rows and their values like a default SQL table. What that admin panel shows you is only a single column and their values. So this, with the help of this str function, we can configure what column we need to show in the admin panel, whether alias, whether cell block, whether status, anything else. If I just rename this to alias, then if you go to the admin panel, you will see the aliases of all the listed inmate in the form of a static bulleted list. Okay, but we will not do any kind of changes. Let it be, because name is the primary thing which any super admin or medical staff needs to see related to a particular inmate at first. Okay, at first glance. Now coming on again to the our request lifecycle. So here you now have understood what this 31 code line is doing. It is fetching all the rows from inmate profile. This is the first job that our backend is doing once it receives this particular endpoint request. Now the second job, permission underscore classes. This is handling the permissions, whether the requested user is allowed to access a particular resource or not. Okay. So for example, we just talked about in solution architecture that only super admins should be able to move inmates, sorry, admit inmates, right? So if you call this particular endpoint as a medical staff or any other group user, this is the exact code line which will deny your request, because you will bypass this is authenticated check, right? Because you are authenticated. But strict Django model permissions ensures that you should be having proper permissions in your group to handle these types of endpoints. Okay, so if we call this endpoint as a medical staff, we all know that, and we all discussed that medical staff is not required to admit an inmate. Only super admins can do that. So strict Django model permissions will go and fetch your user ID, then go to the groups table, filter out with your group with your user ID, and sees what all informations your particular group is having. Then it finds that, okay, medical staffs are not allowed to admit any inmate. This will just throw an error. If you are an super admin, it will pass your request to the below code lines. Okay, let me show you how I exactly have implemented strict Django model permissions. So this is underscore authenticated is a default permission handler. Okay, so I'm not going to show you how it has been implemented. Neither should we care about that, but we should at any chance care about how I have implemented this, because this has been wrote custom by me. Permissions under .py. This is the file where I have defined all our permissions, right? Whether you are a super admin, whether you are a security staff, and this is the like the universal permission controller across my Django project. So this is the default permission handler, right? Django model permissions. I guess you are aware about this if you are literate in Django. What this does, exactly what I told, it will fetch the group the particular requested user belongs to, sees what all informations that group is having, and then request admit the request or reject the request accordingly. But there is a serious flaw in this default permission handler by Django. What it does, it by default allows everyone to have get access to each and every model as long as they are authenticated, which I never wanted from the starting of my project. I wanted that if I as an admin allow you to view any profile, any table, only then you are allowed to view. There shouldn't be a default get access to everybody, right? I don't want to show my audit log table to every public visitor. Why should I? So that's why I have overridden this default Django permission handler with my custom strict Django model permissions class, and I have enforced the get check as well. So that's all I'm doing here. Okay. So this is the view underscore model name permissions, which is the exact permission I am talking about here. If you are having view underscore model name permission, whatever model you will classify here will automatically get the permissions accordingly, right? So here model underscore name is kind of a system variable which will dynamically fetch the model according to what you have requested in the postman. So this is like a system magic. Okay, we don't need to worry about how it has been implemented. So this was all my custom permission handler is doing. Now coming on to the third code line, serializer class. We all know the job of serializer, right? What a serializer does, if it is a read request, serializer fetches all the data from the database, beautifies it in the form of a JSON object, and then returns to the postman interface. If the user has a update kind of request, for example, create, delete, update, this request, what it does, this this possesses the capability to change the state of the database, right? Whether you are creating, whether you are updating anything, or whether you are deleting, you are basically changing the current state of the database, right? So with regards of requests like this, what serializer does, serializer has the job of taking intelligently your JSON inputted data, converting it into a language which database understands, in this context SQL, and then perform a successful post request. So this is the job of users according to that. Now there we are having another code line that is for filters and paginations. Okay, so these two concepts are very much similar to each other. Filters help us filter out the long list of JSON returned object from the database into whatever we want. For example, we suddenly got 1,000 rows of all the current employees, so we want to filter out only those JSON objects whose name starts with A, or only those JSON rows who has the address somewhere near to Bengaluru. Okay, so these types of filter we can, if you want your backend users to implement these kinds of filter in the Postman object, you can implement these types of code line. Okay, so I will show you how exactly I have implemented the filters inside filters.py file, which resides under the same app we are talking about. I have implemented few filters. Okay, so here you can see this is the syntax of defining our custom filters: name, cell block. That's all. I have implemented only two types of filters. So the users of my backend project will be able to filter by name, will be able to filter by cell block ID. That's all. Now here, let's come to the pagination. What pagination does is pagination prevents all the rows to get output at once. So we have defined page underscore size equals to 5. That means if a particular endpoint contains 10 number of rows, the thrown JSON object will contain only 5 rows. If you want to view the next 5 rows, you should simply tap the next button in the front end. Okay, if you are in the backend, that is Postman, you have to go to the system generated URL, which DRF will itself generate for you right in the JSON response. You will simply click that URL, a new Postman request will open, automatically send the request on your behalf, and there you will be able to find the another row that is from 6 to 10. So this types of pagination is working just like that. What this code line says is, under the URLs, whenever you will apply pagination, right? So in the whole endpoint URL inside your Postman's relevant input field, what you will see there, uh, if I have applied page underscore size, we will see page underscore size equals to 10, which will depict the user that, hey, you are seeing the paginated response. This is not the entire response of the database. We are keeping some responses on our back. We are not showing you that because of the load or whatever the reason is, but the pagination is implemented. If you want to see those responses, you will have to move as a back and forth, and according to that, we will be showing you those responses. Max page size equals to 20. Same condition, no difference. Now this is the most important security feature. We are only whitelisting get request, post request, and patch request. Okay, in these types of endpoint, and that is the reason why in our README documentation related to inmate management, you will see only these responses: get, post, and patch. This is exactly what we have whitelisted here. If you will hit put request, delete request, Django will just gonna deny your request because we have not whitelisted here there. So, and let me tell you one more fact here. Via seeing at a gross level, you might be thinking, okay, these are just variables, right? These are just variables. Where exactly we are using these variables? And when you say that this code line is doing the job of serializer, this code line is doing the job of whitelisting endpoint, this code line is doing the job of fetching all the rows from the database, where exactly we will be able to see those logics implemented? I would say we need not to see those logics, right? So those are controlled internally via Django. What we need to remember as a continuous Django developer about those ghosted commands, about those ghosted code lines, about those ghosted backend logics, is that for any particular functionality, for example, this we have talked about, right? For example, permissions, for example, serializers, they look for these variables only right here in this location. So this is a kind of a high level logic that has been fed to those ghost code lines that, hey, right beneath the definition of the view set, user will define these types of variables, and user will define these types of corresponding values to each variable. What you need to do, Mr. Ghosted code line, you need to, for any particular function, go to this particular location, analyze the value which user has fed himself, and then work accordingly, right? So if we will define some another serializer here. What that ghost code line will do, it will take that particular serializer to perform this any kind of action over this inmate profile. Okay, so now same here, let's now look at to the low level exact logic, how the response is being handled from the backend. So what we have asked from the Postman is to admit an inmate, right? We have given the post request. Now saying in the low level logic, what is the exact function which overrides the default post handler of Django? It is, where is the function? Yeah, this one is create. I will explain you the prerequisites before delving into each of these code lines. Okay, so whatever you will put as a request method here, right? Get, post, delete, whatever it is, we are having a particular request handler. We are having a function which handles that request. Okay, so and that particular function is implemented as discussed by default in Django's internal. Those are hosted code lines. Okay, we just need to remember within the context of this endpoint that for post request we are having a host function called create. This create function actually handles from inside the Django's internal the job of fetching the database, analyzing the input, validating whether the input stand by to the attacks like SQL injection or not, and then doing the safe post operation over our database along with outputting proper status code messages and all. So this has been handled internally via Django for us. We are only overriding some functionalities of that particular hosted code line, and then after overwriting, we are returning the steering of that particular car again to that hosted code line. So we are not completely redefining that particular function. We are only editing some details inside that already implemented hosted function, and thereafter returning the control again to that particular hosted function. This is the high level logic which we always need to remember in our mind whenever we see any overridden create function over anyone's views.py file, not just mine. Now let's look at the particular detailed refinement which we have done here. Block underscore name request.data.get cell underscore block. This code line is simply fetching the block underscore name which we have defined in our sample payload. See this one. We are gonna define a cell block that we like inmates just cannot come to the asylum out of the blue. We need to define in which cell block the super admin wants to admit that inmate into. Okay, so that information, how our backend will fetch that information from the particular inputted JSON object via this code line. Now after getting the block name, we are doing some kind of if and else checks over that data. If block underscore name block equals to cell block dot objects dot get name equals to cell block. This code line is simply doing the job of fetching that detailed row of particular block from the cell block. So we have seen in the cell block, right? For example, we have defined block number C. So this particular code line will fetch the exact name of the cell block C from the cell block model and the max capacity of that particular cell block. The default value is 10. Okay, so think details like this code line will fetch. Then if we get some kind of error fetching that code block, okay, so what we will do, that is what this accept code line is all about. If the cell block doesn't exist, simply throw an error that this cell block does not exist, and hence you cannot be able to admit that particular inmate. So you need to send again the same postman payload but with altered cell block value, something which exists in our database. And at a high level, I'm telling you, cell block names from A to E exist in our system. Cell block A, cell block B, cell block C, all the way to E. This is currently my implementation of cell block. You can always modify that. Okay, now here, let's suppose the cell block actually exists in our requested payload, right? So we have given a valid cell block value while admitting an inmate. What will happen after that? The compiler will get into code line 60, and here it will compare the values with our current count versus the max count. So block underscore current count. If you go to the block definition, here we are having a function that is current underscore count. This function is simply returning the current holdings of that particular cell based on how many inmates that particular cell block contains. So you can see the code line self.inmates.filter. It is only counting the inmate which are active currently. So based on this function is returning a value which is the current capacity of that cell block. Now our code line here in 60, the backend is simply comparing the current holding of that cell with the max capacity that cell can hold. Okay, so let's suppose according to the default value what we were having the max capacity equals to 10. So a particular cell block B can hold only 10 inmates, and the current count of that block is 7 inmates. It means how much space is left there. That block can still hold 3 more inmates in that. If this checks gets a red signal, for example, the block is full, we cannot transfer the inmate because the block is full, please use any other block underscore name. We are returning that particular error message. Is at full capacity, transfer or discharge an existing inmate first if you want to admit this particular inmate. Okay, this will run whenever this condition fails. If this condition passes, then we are simply returning all the control over the hosted actual create function, which has been handled by Django. So if it passes, okay, if this request passes, what that practically means? That practically means we provided a valid cell block, and that cell block is able to handle new inmates. So why don't admit this particular inmate? So the job of actually admitting and thereafter throwing the proper response, throwing the proper JSON object for the confirmation that hey, we have updated this inmate. All sorts of this default post job is being done by our existing host function. So that is how you will request this endpoint from Postman, and then that is how you will be receiving a particular corresponding relevant response in your Postman as a response. So in this way, You can inspect each and every logic for all the endpoints here. Okay, whether it's the medical record, whether user group management, cell block dashboard, whatever it is, you can explore all these API endpoints, and basically you will know all how this Arkham Asylum is working. So go ahead, guys, clone this repository, try in your local environment, and most importantly, if you are a front-end developer, try to build a UI over this application and mail me or comment me or reach out to me. I would love to see that particular web application, which has been literally made by my own handwritten API endpoints. If you are a front-end developer, I would kindly request that. If you are not, you just explore this application via Git cloning into your own local ID environment and let me know what all enhancements I can do there.